Let's look at an example in which we have literal exponents. Still works the same way. We have 3x to the 5n times 2x to the negative 3n. I want to group my numbers together, the 3 and the 2, and group my powers of x together. X to the 5n with x to the negative 3n. So by the associative and the commutative laws, I can change the order of grouping and multiplication any way I want to. So I put the 3 and the 2 together. I put x to the 5n and x to the negative 3n together. Now 3 times 2 is 6. To multiply powers having the same base, I keep the base and add the exponents. So it'll be 5n plus a negative 3n. Or I get 6x to the 2n. 5n plus a negative 3n is 2n. Now let's consider another problem. Let's look at 12x to the 4th divided by 3x cubed. Using the definition of exponents, I can expand it as 12 times x times x times x times x, because x to the 4th tells me to use x as a factor 1, 2, 3, 4 times, over 3 times x times x times x, because x cubed tells me to use x as a factor 3 times. Now I can reduce, say 3 goes into 3, 1, 3 goes into 12, 4, and x goes into x1, x goes into x1, x into x1, x into x1, x into x1, x into x1. So I'm left with 4x. 4 times 1 times 1 times 1 times x is 4x over 1 times 1 times 1 times 1 is 1. And of course 4x divided by 1 is simply 4x. Well, now this brings up a new rule, because notice what happened. My exponent is now x, or x to the first power. Well, how else could I have gotten x to the first power? Just look, if I subtract the exponents. Keep the base x, subtract the exponents. 4 minus 3 is 1. So we get another rule. To divide powers having the same base, keep the base and subtract the exponents. And that's the top exponent minus the bottom exponent. So to divide powers having the same base, you keep the base and subtract the exponent. It's the top exponent minus the bottom exponent. Symbolically, x to the a divided by x to the b is equal to x to the a minus b. You keep the base, subtract the exponents. The top exponent minus the bottom exponent. And we do have to assume that x is not 0 to avoid the division by 0 error. This rule allows us to simplify expressions involving division with large exponents. Let's simplify x to the 123 divided by x to the 70th. X to the 123 divided by x to the 70th. Well, to simplify powers having the same base, and they do have the same base x, then I keep the base and I subtract the exponents. The top exponent minus the bottom exponent. So it's going to be x, the 123 minus 70. Either do that in your head or use a calculator to get the answer as x to the 53rd. Look at another example. let's consider x to the negative 9 divided by x to the negative 2. Well, notice we are dividing powers that have the same base. To divide powers that have the same base, I keep the base and subtract the exponents. The top exponent minus the bottom exponent. Top exponent negative 9 minus the bottom exponent negative 2. Now be sure to put this step in. Practically everyone that tries to do this step in their head will make a sign error. So make yourself write in the step. The top exponent minus the bottom exponent. Now to subtract, you have to add the opposite of the number being subtracted. So this would be a negative 9 plus the opposite of a negative 2. So it would be a negative 9 plus 2. So be sure to put in that step. And now once you change it to addition, you can easily add to get x to the negative 7. Negative 9 plus 2 is negative 7. Now you want to remember that your answer should not be left with a negative exponent. A negative exponent tells you to take the reciprocal of the base. So I can write it as, excuse me, 1 over x to the 7th as my answer. Let's look at one more example before I give you some exercises. Let's simplify 72 x to the 9th y cubed divided by 9 x squared y to the 5th. 72 x to the 9th y cubed divided by 9 x squared y to the 5th. I can regroup so that I have my 72 divided by 9. I have my x to the 9th divided by x squared because they have the same base, and my y cubed divided by y to the 5th because the y's have the same base. Now if you're wondering if this is really true, think about how you multiply fractions. You multiply numerator times numerator times numerator, and denominator times denominator times denominator. Well, if I actually multiply out 72 times x to the 9th times y cubed, I get back to the problem. If I multiply the denominators, 9 times x squared times y to the 5th, I get back to the problem. So you can see that it is indeed legal to do that. Now I want to do the 72 divided by 9. 72 divided by 9 is 8. And to divide powers having the same base, I keep the base and subtract the exponents. Top exponent minus the bottom exponent. So it'd be x to the 9 subtract 2. Then y to the 3 subtract 5. Top exponent minus the bottom exponent. Doing the subtraction, I get 8 x to the 7th y to the negative 2. 9 minus 2 is 7. 3 minus 5 is negative 2. 8's okay, x to the 7th is okay, but y has a negative exponent. A negative exponent tells me to take the reciprocal of the base. So I need to write it as 8 x to the 7th times 1 over y squared. Now notice y is the only base that has a negative exponent. So y is the only thing I do the reciprocal of. Now this is understood to be 8x to the 7th over 1. So then multiplying, I get as my answer 8x to the 7th over y squared. 8x to the 7th times 1 is 8x to the 7th. 1 times y squared is y squared.